Have you ever just looked at a map and really wondered why? Why is everything arranged the way it is? Why do these huge, sprawling cities pop up where they do, while other places stay small? Well, today, we are pulling back the curtain on the secret logic of cities. Because, it's not random. It's not like someone just threw a bunch of darts at a map and decided, yep, that's where New York goes. There are very specific reasons why some places become global hubs, and we're going to crack that code together.
And that's the secret right there. What looks like total chaotic sprawl is actually a super complex system, and it has its own set of rules. And to understand those rules, we have to start with one big foundational idea.
At the very heart of this is the concept of an urban hierarchy. See, not all cities are created equal. You've got your global powerhouses, think London, Tokyo, offering these really specialized high-end services. And then you've got smaller towns that provide the everyday stuff. It's like a ladder, a ranking system, and it's the key to everything else we're about to talk about.
So, if cities are ranked, the first big question is there some kind of mathematical pattern to their size? Well, it turns out geographers have two really interesting competing theories for this.
Let's kick things off with the first one, the rank size rule. Now, I know it sounds a little technical, but the idea behind it is actually beautiful and simple. It basically suggests that in a balanced country, the second biggest city will be about half the size of the biggest, the third biggest will be about a third the size, and you just keep on going down the line. And the United States is a pretty textbook example of this. You take New York City as number 1. Well, Los Angeles, at number 2, has about half its population, and Chicago, sitting at number 3, has roughly a third. This pattern usually points to a really healthy distributed economy, where one city doesn't just suck up all the resources. But not every country works this way.
So now let's look at the polar opposite, the primate city rule. A primate city is like a giant sun in a solar system, with a bunch of tiny little planets orbiting it. It's this one single dominant city that is so massive it just completely overshadows everything else in the country.
You really can't find a clearer example than Mexico City. It's not just twice as large as the next city, it's almost 4 times larger than Guadalajara. This creates a totally different kind of gravity, where everything, the economy, politics, culture, it all gets pulled into this one central place.
So let's put these two models head to head. The rank size rule, that suggests balance, spread out opportunities. You see it a lot in developed countries like Germany or the US. The primate city rule, on the other hand, means imbalance. All the resources are concentrated in one hub. This is pretty common in developing nations or former colonies, where maybe one port city became the center of all trade. And it can be a huge engine for growth, but it can also create this massive gap between the capital and, well, everywhere else.
Okay, so we've covered size, but cities don't just exist in a bubble, right? They interact, they trade, they influence each other. So how can we predict how strong that connection is?
For that, we turn to the gravity model. And yes, it is named after Newton's law of gravity for a very good reason. The logic is exactly the same. Just like huge planets have a stronger gravitational pull, bigger cities do too. And just like planets that are close to each other pull in each other more, so do cities.
Let's break that down. Proximity is a huge factor. I mean, just think of the constant flow of people and money between New York City and its New Jersey suburbs. They're basically one giant connected zone. But here's the cool part. Size can actually overcome distance. New York and LA are on opposite sides of the country, but because they're both such massive centers for finance and entertainment, they have this incredibly powerful bond. This model is super important for everything from planning airline routes to predicting trade flows.
All right, so we've got size and we've got connection. Let's dig into our final classical theory, and this one explains the actual physical spacing of cities and towns based on something we all do, shopping.
Oh, I love this theory, because it's something we all just get intuitively. It's called central place theory, and it gets right to the heart of why you can find a convenience store on every other block, but you might have to travel for hours to get to a major airport. And it all boils down to 2 simple ideas. First up is threshold. This is just the bare minimum number of customers a business needs to survive, to keep the lights on. A little corner coffee shop might only need a few hundred people, but a giant football stadium, that needs millions.
And the second piece of the puzzle is range. This one's about you. It's how far you are willing to go to buy something. You'll probably walk 5 minutes to grab a coffee, right? But you might drive 5 hours to see your favorite band play in that giant stadium.
And here's where it all comes together. Low-order goods, like your weekly groceries, have a low threshold and a short range, so you find them everywhere.
But high-order goods, things like a super specialized neurosurgeon, well, they have a massive threshold and a really long range. People will literally fly across the country to see them. And that's why you only find those kinds of services in the biggest cities, the central places. This has huge implications for things like access to healthcare.
So these theories are fantastic. I mean, they were developed about 100 years ago, and they gave us this powerful new way to understand the world. But does that lens still work today?
This is the big question for geographers right now. Chris Dollar was thinking about a world where people walked or maybe took a horse and cart. The gravity model came about before commercial air travel was just a normal part of life. How do these rules hold up in our world?
Well, there are definitely some limitations. For one, these models kind of assume the world as a big, flat, empty plain, but in real life we've got mountains and rivers in the way. They also tend to focus on economics, but sometimes a city is important because it's a political capital. But the two biggest game changers, modern transportation, which has totally warped our idea of range, and, you guessed it, the internet.
As one expert put it, the internet allows for the purchase of goods and consumption of services without leaving the home, potentially rendering the physical spacing of the model obsolete. I mean, think about it. When you can buy almost anything with a click, what does range even mean anymore? The internet is fundamentally rewiring the entire logic of place.
And that's the thought I really want to leave you with. These classic rules, they still give us an incredible foundation. They help us understand the world we've built. But as technology cuts the cord between work, shopping, and where we physically are, you have to wonder, what new rules are we writing right now? What is the secret logic of the cities of the future going to look like?